So this is the other data and statistics chapter from my book, Overcoming Digital SAT Math. So this chapter is kind of like the data analysis chapter in a way, a little bit, like you'll see some similarities, but most of it's like make the best conclusion off of, or like what's the best conclusion based off of this information we're giving you about this like particular survey or study, like those types of analytical questions, like mean, median, mode type stuff, that kind of thing, margin of error, yada yada. So that's why I have this little like highlight right here, just to save you some like pain and suffering. Just remember that when you increase sample size, you decrease the margin of error, because think of margin of error as like the percent that you're expecting to be like off in your estimation. So if you're expecting to get like 80% of people do something and you say you have like a 5% margin of error, it means like you're expecting about 80%, but you're also expecting like probably to be off by like 5%. So like it's probably going to be like between 75 to 85%. If that makes sense. It's like that, how much you expect to be off, sort of, is the best way to think about it, I think. So just remember, if you increase the sample size, like when we're talking about like doing a survey or something like that, you decrease the margin of error. And also attempt to do these problems on your own first before watching this video for help on anything that you can't correct on your own for the best results. And pay attention to the video description over time for links to other helpful videos and stuff. Okay, so let's get started. Now, pause to read number 1 if you haven't already. So I always start out, if something's asking me about median and something else, I always start by just automatically listing out the data points, or scores is another way they're referred to. In terms of least to greatest, you could also do greatest to least. I just prefer it this way. And then that way I can just easily see what the middle number is. Now, in this case, we have an even number list, so we're going to have 2 numbers in the middle right here, you'll notice. It's 0 and 4 are the 2 numbers in the middle. So when that happens, we can't just automatically say what the one middle number is. We have to instead take the average of those 2 numbers, which means for the median, we have to say, okay, we're going to do 0 plus 4 divided by 2, and that's going to give us 2 for our median. We can also, now that we have it least to greatest, easily figure out what the range is, because that's another thing that was asked of us. So the range, ooh, that was a terrible R. The range is going to be the high minus the low, so 9 minus -5 is the low. Remember, minus a minus is just addition. So that would be 14 as our range. So I always just start with like the easiest stuff, you know? And mode is also an easy one here. So if you look for mode, you're trying to figure out which number occurs most frequently in your list, basically. And each number appears only once. There's no number that's repeating more times than the other numbers. So there's no mode in this case. So mode equals none. There is no mode. It's a trick question. And then the mean is going to be the sum of all these data points divided by how many there are. So we're going to add all those numbers up and divide by, there's 1, 2, 3, 4, 5, 6 of those numbers. So that's what I'm going to do. And when I solve that, I'm going to get that the mean is equal to 2. Okay, pause to read number 2 if you haven't already. So for this problem, we want an estimate based off of 3,000 total absences, the best estimate for the number of sickness-related absences for sophomores. So let's look where it says sickness and sophomores. So that means we're talking about 80, because that lines up there. And then in the corner over here, we have the total number of all the students that we're discussing. So it's 80 out of 305 students that we're discussing if we're talking about the desirable outcome, the 6 sophomores on top, out of the total number of outcomes, which is the total number of students on the bottom. Now we're going to multiply that by the 3,000 total absences, because this is saying that this is the fractional amount of students that fit this criteria. So if we want to find that fraction of some other total number of students, we just need to multiply by it. So that's what we're going to do here. And when you do that, you get 786.885, yada, 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 forever. And then, so what's the best estimate? That would just be closest to C, 787. Okay, pause for number 3 if you haven't already. So what we're going to do here is we're going to write equations for 2 different situations. So these are the 2 equations I would write. The first one is saying, okay, we have the mean of 35 years equaling the sum of all 10 employees' ages divided by the 10 employees. And then the second instance is like once the manager leaves, then we would say the mean is 32 years and the mean is equal to the sum divided by how many data points you're talking about, or in this case, ages. So it would be the sum of those 9 employees. Another way to say the sum of those 9 employees would be it's the sum of all 10 employees minus X, where X represents the age of that manager that's leaving, because you're taking away his age to get the sum of the 9 remaining employees. And then you would divide by how many employees there are, the 9 employees. So now what we can do is we can solve for sum of 10 up here and then plug that into the second equation and solve for what we really want, which is X. So let's do that. So on top, I'm going to multiply each side by 10 and I get the sum of those 10 employees' ages is going to be 350. So now I can plug that in. Ooh, that was awful right there for sum of 10 and solve for X. So that's exactly what I did, and this is what it looks like. So now I just need to multiply each side by 9, and this is what I get. And then I just need to subtract 350 from each side, and I get this, and then I just cancel out the negative on each side to get that it's 62 years old. That's how old the manager that's leaving is. So the answer is C. Okay, pause for number 4 if you haven't already. And I wrote a little note that says add 1, divide by 2 trick. That applies to when we have an odd number list. Like here we have an odd number of employees. So like we have an odd number of data points in our list because that would be 25. So if you want to ever find the median very quickly without having to like list stuff in order of least to greatest in a whole big list, you could just say, oh, I'm going to take 25, add 1 to it. So that would be 26, divide by 2, and that gives me 13. So that's the rank that I'm looking for. Like if I line up all 25 data points, I'm looking for the 13th number in that list as my median. So let's go ahead and start with finding the median since we were just talking about that. So here the frequency says how many times the corresponding number shows up in a list of data. So like 4 here being the frequency, matching up with 30 means you have 30 4 different times in your list. Like that. That's what that means. Now, I'm not going to write out the whole list because I'm using my trick. So we know it's going to be the 13th number. So this is already in order from least to greatest, so I don't have to fix anything there. So I can just pay attention to the frequency and say, okay, when do I get to my 13th number? So this is going to get me to my 4th number. Then if I add 3, this is going to get me to my 7th number. If I add 2, this is going to get me to my 9th number. And if I add 6, that's going to get me to my 15th number right there. Now remember, we wanted the 13th number, and the 13th number is going to be right over here. It's going to be 45 because we only got up to the 9th number here, remember? So that means that the 45 has to be the 13th number in our list. So that has to be our median. Now I'm going to go ahead and find the next easiest one, mode. So mode is the one that shows up most frequently in the list. So it has the highest frequency. So just look at the frequency portion. And that means that it would also be 45 because there's 6 of them. And that's the greatest amount of data points right there. Greatest frequency, I guess, of data points right there. So the mode is 45 as well. So just from that, we can eliminate half the answer choices. Or actually, I misspoke. We can eliminate these two based off of that, and then we can actually also eliminate B, because I was reading mean as median. But no, the only one that says the mode and the median can be equal is D. So this is something you're likely to see on test day. They love these tables, especially when it comes to comparing data sets. You're probably going to see some sort of data set comparison question with two different data sets like this. So pause to read if you haven't already, and then we'll do number 5. So let's start by finding the mean of dataset G. So you can add up like 70 plus 70 plus 80 plus 80 plus 80 until you get to 980s and so on and so forth. But an easier method is just to multiply the value times the frequency and then add it to doing the same thing to the next row where you multiply the value and then times the frequency again. So this is what it would look like. So now you're going to add that up to get the sum, because remember, mean is the sum divided by the number of data points. So you would get that as the sum and then divide it by how many data points you have, which you would get by adding these numbers right here, the frequencies. So it would be 2 plus 11, or 2 plus 9 is 11, and then 11 plus 3 is going to be 14, and then 14 plus 5 is going to be 19. And this is what you get for your mean for dataset G. Now, I rounded it off to the nearest thousandth place. You're going to get a much longer decimal, just FYI. Now we're going to do the same thing with dataset H. So I did 70 times 3, 80 times 8, 90 times 5, and 100 times 3. And then now I'm going to add it all up to get the sum up on top here. And then I'm going to divide by how many data points I'm talking about, which would be right here if I add all those up. And that also gives me 19 data points there. So on the bottom, I would have 19 again, and then the top is just going to be what all of these are added up. And that gives me 1600. And really, you don't even need to like turn it into a decimal. Some people find it easier to see visually because they have trouble comparing fractions. But you could just know from the denominators being the same and the numerators being different, like this has a higher numerator, so G has a higher mean. So we would have to pick the answer that corresponds with that. So we would have to pick B. Pause and read number 6 if you haven't already. So we're trying to do median. So remember that trick that I talked about a little while ago, where if we have an odd number of data points, which we do, we have 19 in each of our lists, the rank for like what number we're looking for in our list for median can be determined by just taking that total number of data points, which is 19, and dividing or adding 1 and then dividing by 2. So 19 plus 1 is 20, and then divide by 2 to get 10. So we're looking for the 10th number in our list for each of these because they both have 19 data points. So if I want to get to the second number, this would take me to my second number because it would be 70 and 70 again in the list. 9 being the frequency for G means I have 9 80s, like I'm writing 89 different times in my list. So I was at my second number, then I'm going to go 9 more into the future, and that gets me to the 11th number on my list. So that means that one of these 9 groups of 80 is where the median is. The 10th data point is within that. So that means that the median of dataset G has to be 80. So that's what I wrote down here. Now we're going to find out what's the median of dataset H. So we're looking for the 10th number in that list. So this would get us to the 3rd number, and then this would get us to the 11th number if we go 8 more in the future. So the 10th number in that list also has to be 80. So it would be 80 for H, so they're the same. So that would just be C. Okay, pause to read number 7 if you haven't already. So now we want to determine the mode. Remember, mode is the one that occurs most frequently, the data point that occurs most frequently in your list of data points. So another way of saying that is it's the one with the greatest frequency. So the greatest frequency for dataset G is 9, and that corresponds with 80. So that means that 80 must be our mode for dataset G. So let's write that down. And let's look at dataset H. The greatest frequency is right there. That corresponds with 80. So they have the same mode. So it would also be C for this one. Okay, pause to read number 8 if you haven't already. We're trying to determine the range. So remember, range is the high minus the low, meaning like the greatest number in your list of data minus the lowest number in your list of data. So for dataset G, the highest number is going to be 100 and the lowest number is going to be 70. And it's the same thing for dataset H. The highest number is going to be 100 and the highest number for our dataset H, or the lowest number, sorry, for our dataset H as well is going to be 70. So they both have the same high and the same low. So when we subtract that, we're going to get the same number for our range. So the range is the same. So it'd be C. Okay, pause to read number 9 if you haven't already. So remember, mean is the sum divided by the number of data points, which is sometimes referred to the number of items in your list. So we have the same number of items or number of data points in list A and list B. So the number on bottom is going to be the same, but the sum is going to be different because every single number is the same, but except for when we get to this last number right here, list A has a 9 and list B has a 10. So we're adding up different numbers there. Therefore, the sum is going to be different for list A and list B, so we're definitely going to get a different mean. So the means definitely have to be different, so we can cross out A and B now. So now we have to see if the standard deviation is going to be the same or different. So standard deviation is just basically like how far does it deviate from the mean, like how dispersed is the data in relation to the mean. So you're thinking like, if I look at my data points, are they going to be dispersed the same from the mean? Are they going to be, I'm trying to think of a better way to say this. Are they going to be spread out from the mean, I guess is a more like layman's term way of saying it. Are they going to be spread out from the mean the same amount? Are they going to deviate from the mean the same amount? Well, no, because again, same reasoning, you have all the same numbers. Like if it was like exactly the same list like this, then definitely the standard deviations would be the same. But we have those different numbers right there, so they're not going to be the same. They're going to be different, so it would be D. Okay, pause to read number 10 if you haven't already. So what we're going to do here is we're going to, again, mean is the sum divided by the number of items or data points in the list. So to find the mean, we have to add these up to get the sum and divide by how many items are in our list. So this is what that would look like. So now let's combine our like terms on top. So this is what that would look like. Now we know what the mean is. We know it's 800, so let's replace the word mean with what the mean is, 800. And now let's multiply each side by 5. And we get this. And now let's subtract 3,200 to get x by itself from each side. And when we do that, we get that x is equal to 800. Okay, pause to read number 11 if you haven't already. So here we have two equations to represent two different scenarios. So we have that on Wednesday, Thursday, and Friday, we would add up what he spends and then divide by the 3 days to get the average of 86. And then if we're talking about the average of all the weekdays, it would be adding Monday, Tuesday, Wednesday, Thursday, Friday, and then dividing by the 5 weekdays. And we know from the problem that that's going to give us an average or a mean of 82. Now you'll notice that these equations have something in common. They have all of those in common. So if I can figure out what Wednesday plus Thursday plus Friday, like the sum of those is, it from the first equation, I could plug that in to the second equation to help me out. So all I need to do to the first equation is multiply each side by 3. And when I do that, I get that the sum is 258. So now let's plug that in right here. So when I do that, this is what I get. Now remember, the question's asking me to find the mean for Monday and Tuesday. If I want to find the mean of Monday plus Tuesday, this right here, it's equal to the sum of Monday and Tuesday's spending divided by the 2 days that he's spending. So now if I can figure out what Monday plus Tuesday is, up here, I could plug it in here to get the mean. So let's multiply each side by 5 because we're solving for Monday plus Tuesday. And this is what I get. Now I just need to subtract 258 from each side, and I've solved for the sum of Monday plus Tuesday. And that equals 152. So now I need to plug in 152 here, divide by 2, and I have my answer. And that gives me 76 as my answer. So the answer is A. Okay, pause read number 12 if you haven't already. So we want to find the average or the mean of x, y, and z in terms of p. Now the problem gives us essentially these 3 equations. So x is equal to the average of p plus 12. So to find the average of p and 12, it would be p plus 12 divided by 2, because there's p and then there's 12. That's 2 items, 2 things, and so on and so forth for y and z as well. So if I want to find the average or the mean of x, y, and z, I'm going to need to add up x, y, and z and divide by 3, because I'll have those 3 terms. Now, I can't just leave it like this because it says it wants it in terms of p. So what I need to do is replace x, y, and z with what they're equal to that has a p in it. So let's do that. And that would look like this. So now let's add everything on top. And this is what we get. Now, remember, a fraction bar is the same thing as a division sign. And you can kind of remember that too, because like this is the fraction bar and the division symbol, and the dot on top and the dot on bottom are like the blank space for the numerator and denominator, you know? So I can just say that this is 9p plus 50 over 2 divided by 3. So that essentially, because 3 is the same thing as 3 over 1. Now, if I'm dividing with fractions, I have to keep change flip, KCF. So let's do that. So I keep the first fraction, change division to multiplication, and then the 3 over 1 flips to become 1 over 3. Now I just need to multiply it. And I get that when I multiply it, so the answer should be A. Okay, pause to read number 13 if you haven't already. So the problem essentially gives us this information, and we have to compare the mean and median for dataset X and dataset Y. So dataset Y is just all these numbers except the 10. Dataset X includes the 10. So let's start with the easiest stuff, median. So let's find the median for dataset X. Dataset X has 11 data points, so let's use the trick where we add 1 to get to 12 and divide by 2 to get 6. So we're looking for the 6th number in our list, and that'll be our median. So if we're looking at dataset X, 17 is going to be the 6th number in the list, so that's our median, or B in this case. Now let's find the median for dataset Y. So for dataset Y, there's 2 numbers in the middle, 17 and 17, so we have to take the average of that. So 17 plus 17 divided by 2 is just 17. So D would be 17. So B and D have to be equal, so we can automatically cross out 2 of our answer choices here. Now let's find the mean for dataset X. Or actually, it probably makes more sense to start with dataset Y because it has the 1 less number. So let's do that. So remember, mean is the sum of the data in your list divided by how many data points you have. So for finding the mean for data set Y, it would be 16 plus 17 plus 17 plus so on and so forth until you add up all of these numbers right here from 16 to 20. And then you're going to divide by there's 10 numbers in that list. So the sum of all those numbers would be 179, and then you're dividing by the 10 numbers, so that gives you 17.9. Now let's find the mean for data set X. So we know from what we did previously that all of these numbers add up to 179. Now we just have to add a 10 to it to get the sum for data set X. So that would be 189 divided by the 11 numbers in the list. So that's what you would get there. And when you do 189 divided by 11, you get 17.181818, blah, 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 repeating. So basically 17.18. So that's what A is equal to. So obviously C is greater than A. So we need to pick the choice that says that. So it would be answer choice B. Okay, pause to read number 14 if you haven't already. So basically we have a manufacturer with several factories in different states, and we want to figure out what the most appropriate method is to estimate the proportion of all employees at the company who are satisfied with their job. So let's look at our choices. So answer choice A says we're just going to one of the factories, and then we're going to survey each employee at that factory. Remember, there is several different factories within this company. Therefore, if we only go to one of those factories, we're not really getting a good sense of the satisfaction ratings of all of the employees at the company. We're just getting basically a little part of that at that one specific factory. So that's probably not it. Let's go to B now. Now, B is much better because it's saying we're going to do random selection of 20 employees from each of the factories instead of just picking one factory. So that would give you a better sense of overall how the employees are feeling about their jobs at the company. So we can definitely cross out A now. And now let's try C. So C is recommending you just survey the 50 highest paid and 50 lowest paid employees. Now, that opens room for a whole bunch of problems because, I mean, if you're paid very well, you're probably going to be more satisfied with your job than if you're one of the 50 lowest paid employees. You're getting kind of like the extremes in the circumstance. Like, you're not getting any of like the average paid employees, so you're going to probably just have like extreme answers. So it's definitely not going to be C. And now let's try D. So a lot of people end up getting stuck between B and D because they think D sounds great, but think about what could go wrong in these situations. That's kind of how to go about doing these problems best. Think about the potential for bias, the potential things that could go wrong. So if you're creating an online survey, right, and just using the first 100 responses, there might be something about the people that are willing to go and do that survey that's different from the general population that you're supposed to be studying. Like maybe only for instance, we were just talking about highest paid employees and lowest paid employees. Maybe the lowest paid employees don't have access to a computer at home, so they can't fill out the survey as easily, so they're less likely to fill out that survey. Like, you don't know what's going to lead people to go and fill out the survey, like what type of people you're going to get to fill out the survey, and if that's representative of the general population there, because that's not really random. There's going to be a lot of things that can go wrong there, basically. So the answer is B for sure. Okay, pause for number 15 if you haven't already. So we want to have the lowest possible margin of error, and this researcher is conducting a survey to find the mean number of books read by a particular group of people each year. So which of these would be the best sample to have the lowest margin of error? Remember, margin of error is kind of like how far off things can be. I like to think of it as like the potential for error. So if we want our estimate, or our mean in this case, to be off by the lowest amount possible, we want to pick people whose answers are going to be very close together, basically, like very similar. So when we're reading through the answer choices, let's think, are these people who would be answering the question, how many books do you read per year? Is this a group of people that would answer that question very similarly? Or in this case, the most similarly to have the lowest margin of error. So out of these options, the ones that are most likely to answer that question most similarly is going to be D, the students who are taking the same literature course, because they're literally taking the same course. So they're probably having like a syllabus and like a reading schedule and like assignments and stuff that depend on a particular set of books that they have to read. So that's probably going to be the best answer here. The other answers are going to be way too far off. Like residents of the same town, like probably don't all have similar reading habits, you know? While romance book readers might like the same genre, like there might be someone who reads like one book a day and someone who reads like one book a month, like, you know? That doesn't really like have a set schedule to it or anything that's like standardized in a sense, like how a literature course would have some sort of syllabi. So, or syllabus, I guess. And then shoppers at a particular bookstore, kind of like more similar to the residents of the same town. That just tells us that they go to that bookstore and that they read, not that they read the same, like on the same schedule in any way. So it would be D. Okay, pause to read 16 if you haven't already. So for this problem, you're going to have to remember that the larger the sample size, the smaller or lower your margin of error is. So we want an explanation for why John obtained a smaller margin of error than Alyssa. So let's think. John needs to have the greater sample size if he got the smallest or smaller margin of error between the two of them. So the one that says that would be answer choice D. Okay, pause to read 17 if you haven't already. So for this one, remember that margin of error is how far off you're expecting your results to be from your estimate, kind of like how far off it possibly can be is margin of error. So keep that in mind when reading through the answer choices. And actually, I was just going off my memory. I didn't even read this problem yet. I was assuming that it was the problem I originally put there, which, because I put all the margin of error problems next to each other, this is a completely different problem. So forget what I said. This one's correlation versus causation and positive and negative association. So remember, correlation does not mean causation. So like you can't say because things are correlated, like that something, one trait increases as another trait increases or something like that. You can't say that one causes the other to increase as it increases. Like you can't say cause. You can just say that they're correlated. But you can't say for sure that one thing is causing another thing to happen if they're just like associated with each other, you know? So basically, correlation does not equate to causation. Just remember that. So we're saying that as we have higher anxiety levels, that's going to be associated with more time on social media. So that's just represented visually right there. So let's look at our answer choices. And we're going to see what best supports what we've just gone over. Now, right away for C and D, I'm seeing caused. So I already know it can't be C and D because remember, correlation does not equate to causation. So let's cross those out. Now, we have to determine is it A or B based off of if there is a positive association or a negative association. Now, in this case, there's a positive association because as one thing increases, the other thing is increasing as well. So basically, positive correlation is like both things are doing the same thing. So like they're both increasing or they're both decreasing. So as one increases, another increases. As one decreases, another decreases. And if you're looking at a scatter plot, it's going to look something like this if you have a strong positive correlation. It kind of looks like like as if we were to draw a line in between there, like a positive slope line, but with dots is usually how you see it. Like all kind of together like that. So the answer has to be A. Now, really quickly, because I know people are going to have this question, what is negative correlation? Well, negative correlation would be like, say that as anxiety increased, social media time decreased. So this would be negative correlation because like they're doing the opposite of each other. So that would look like this if it was a strong negative correlation. So basically, like if you're envisioning like a line on the scatter plot, like it kind of looks like a line with a negative slope where all the dots for the scatter plot are like pretty close together to have that strong negative correlation or association. So you see like the social media time is this axis, so that keeps on decreasing as we increase along the anxiety axis. So as one is decreasing as the other increases. So that would be a negative correlation or negative association. Now, if you have something like this, those are supposed to be dots, I know, sorry, where there's like no rhyme or reason kind of to it that you're seeing, very different than the other ones, this would be that there's no correlation. Okay, pause for number 18 if you haven't already. Okay, so Yifan is at Briar College and she's surveying 30 students in the cafeteria about their favorite sport to find out the most popular sport. And she finds out of those 30 students she surveyed, based off of that the most popular sport was football. Which of these is most likely true? So, again, with a lot of these questions, think like, what's wrong with it? Like, kind of like nitpicking in a way. So A says football is the most popular sport at Briar College. She only surveyed 30 students at one singular cafeteria. There's so much that can go wrong there. It could have been maybe like in a lot of colleges they have like a specific dorm or with a specific cafeteria for people that do sports. So maybe she went to that one that was maybe for like the football players typically go to. Or there's something about that cafeteria that just leads those students to be not representative of the general population at Briar College. Like there's something specific to that cafeteria. Like you don't know. You're not getting a good sense of everybody at the college. So definitely not A. So B is saying you basically shouldn't say what is the most popular sport because the sample size is too small. Now, while the sample size is pretty small, I would say that it's more of an issue of where Yifan was conducting the survey and how it was very it was very specific to like that one particular place, which is probably not representative of like all the different students, because who knows what is specific about that cafeteria that could be different. Like it just opens up room for bias. So it's probably not the sample size, but we're gonna keep going. So the sampling method is flawed and may produce a biased estimate of the most popular sport at Briar College. That's basically what I've been saying this whole time. So yeah, it's definitely that one. Well, I don't want to say definitely because we should keep reading. So D, the sampling method is not flawed and, well, it's definitely flawed. So let's just stop there. Okay, C. Okay, so pause to read number 19 if you haven't already. Okay, so we want to know which of the following is an accurate conclusion. So A says if all listeners had voted, song B would have won. That's definitely wrong because it says that there was an estimated only 15% of listeners that voted. So the information we have right now is just based off of a very small percentage of listeners voting, 15%. We can't say how the other 85% would have voted. So definitely not A. Now, B is one that I see get a lot of students into trouble sometimes because you guys are letting your own bias affect how you answer things. So for B, it says listeners voting by call were likely to be older than listeners voting by message. There's no information here that leads us to believe that. Just because you might be used to like your parents and stuff calling instead of texting or whatever does not mean that the people voting by call were likely to be older. There's nothing that gives us anything to think that here. So definitely not B. And then C, if all listeners who voted had voted by call instead of by message, song B would have won. So the reasoning why it's not C is kind of like A's reasoning. Like that's way too general of a statement to say, like, if all the listeners who voted by call instead of by message, like, then song B definitely would have won. Like, there's nothing that can lead us to make that concrete determination here. And you also have to remember, these are percentages. So, like, you have to keep in mind that, like, the number of votes is not, like, exactly corresponding to these in, like, in actual numbers. Like, 60% of the votes being cast through calls, like, that's, like, 60% of the total votes, right? But then when it's saying, like, song B earned 75% of the votes cast through the calls, like, we don't know how many votes the 75% is based off of to, like, make those concrete determinations like that, if that makes sense. And one trick that you can use on a lot of these that you might be seeing a pattern now is, like, you don't want to go for extremes. Especially when it comes to, like, statistics, we have to be very careful. Like, that's why the whole, like, that's kind of part of the whole correlation versus causation thing. Like, you finite statements, like, this is absolutely doing this, like, sort of things are kind of frowned upon. So a lot of the times those definitive statements are not the correct conclusion. So let's look at D. Listeners voting by call were more likely to prefer song B than were listeners voting by message. You see how, like, that wording is a lot better than, like, C, for instance, which is saying, like, they definitely would have won. Like, song B would have won. Like, it's just saying that listeners voting by call were more likely to prefer song B. Like, that's not as definitive of a statement. So let's see. Well, song B earned 75% of the votes cast through call and 45% of the votes cast through messages. So that tracks. Like, they were more likely to prefer song B. So the answer has to be D. Okay, pause for read number 20 if you haven't already. So this is essentially what we have for the three data sets in terms of information. I've just written it out in an equation format. So this is the given information, right? For A and B, just straightforward what was given, that what the mean is, and that it's equal to the sum of all of A's data points divided by the 68 values or 68 data points. And then B, the mean is 74, which equals the sum of all of B's data points divided by 56 data points, right? Now the mean for C is going to be, well, C includes all of A's data points and all of B's data points, so it's going to be the sum of all of those, which is the sum of A plus sum of B, divided by the total number of data values or data points, so 68 plus 56. So essentially, to figure out the answer to my question, which is asking me to find the mean of C, I have to figure out what sum of A plus sum of B is. So let's solve for sum of A and sum of B and then plug it in here to solve. So I just need to multiply each side by 68 to get sum of A by itself, and I get that it's 3060. Now let's multiply by 56 on each side over here to get sum of B. So when I do that, I get sum of B is equal to 4,144. Now let's plug in that plus that up here. And when I do that, I get this. So now I just need to add this and then divide by this added up in my calculator. And when I do that, I get a decimal that goes on forever, and I just need to round to the nearest whole number, it said, so the nearest whole number would just be 58. So that's my answer.